Hi friends, how are you? In this video clip that is on dyeing, please subscribe to my channel Gurvira Textile and Fashion Technology Tutorials. Friends, see today's this class that is on acid dyes. Friends, please watch my previous classes in my playlist on dyeing library. I already taken the introduction class to acid dyes. On acid dyes, that is brief class is there. But now it became a popular video clip. Many of the audience in the world they're watching. See, please watch what I'm saying. Please watch acid dyes. After that, if you watch this, that will help. See, acid dyes, you know, generally we can talk acid dyes. Acid dyes are used to dye the textile material made of what? Protein fibers. See, protein fibers means what are the fibers are coming? In natural category, silk is a protein fiber, right? And in synthetic category, nylon. Okay, nylon is a protein fiber. Nylon is not a protein fiber, it is a chemical synthetic fiber. But silk, in natural category, silk and wool are the protein fibers. Silk, the yarn or fiber, contains the chemical substance that is fibroin. Okay, and the wool, the chemical substance present in the wool fiber is keratin. These are a protein. I'm not talking about the morphology of the silk or wool or synthetic fiber nylon. But these three kinds of fibers are dyed by the dye acid dyes. It is a common acid dye used for protein fibers and for nylon. See here. And one more point here, I would like to say here that as any dyes you take, in general I'm talking dyes, most of the dyes are soluble in nature. Soluble means in what? Whether in water or in any chemical solvents. Yes, water, I'm talking water. The dyes which are soluble in water, those are called soluble dyes. Some dyes which are not at all soluble easily in the water, they need extra agents, extra chemical agents is required to make them soluble. This is the main idea in any chemistry. Chemistry includes solution, solvents. Okay, solutions, solvents, whatever its meaning is in chemistry. In this solubility, soluble, these are words are coming. Any dyes we take, that is soluble dyes are there, insoluble dyes are there. Like that, in this acid dyes also, there are two types of dyes are there. Acid dyes are classified in different ways. Example, I'm saying textile fibers are classified as animal fibers, vegetable fibers. Okay, I'm taking just an example. And again, in this is one category. And second category, again fibers are classified as natural fibers, regenerated fibers, synthetic fibers. This is one category of dye class. And another class, how they are classifying the fibers. Fibers are classified as vegetable fibers, okay, or plant fibers or seed fibers, like that. So in that way, textile dyes are also classified in different ways. When the topic comes soluble and insoluble, this is one category, this is one way of classifying the dyes. What I am taking the class briefing here, that is the way of soluble and insoluble category. Next class, I am taking another way of classifying acid dyes. This class, what I am taking the class is based on the solubility of the dyes in the solution, in the water. Okay. See, acid dyes are classified, okay, acid dyes are classified based on their solubility in nature. One is molecularly split acid dyes and second one is aggregated acid dyes. I have not written here aggregated acid dyes. That I will take next class, next class. Because I wanted to give videos only within 20 minutes. That's why. molecularly split dyes and aggregated acid dyes. Molecularly split means the title itself saying whatever the dye molecules are there, the dye is in the powder form, the dye is in the paste form, or dye is any form, in any form available in the market. If added in the water, that immediately soluble mixed with the water, like salt in water, like sugar in water. Understand? The dye, powder or paste, if we add in the water, that's all dye molecules are split, immediately dispersed and clubbed or mixed with the water. That solution becomes dye solution, dye bath. For that, no reagents are required. Readily available dyes, that is molecular split dyes, are not required. Any extra chemical to add, any extra reagents to add, activators to add, nothing is required. Okay, na? Such dyes are called what? Molecularly split dyes. Molecularly split dyes. Okay, na? And another class, what I'm taking next class, that is aggregated dyes. Aggregated acid dyes means in that if that class of dyes, if add in the water, what will happen? That is not easily soluble in the water, because the lumps of the molecules, that is cluster of the molecules, that is group of molecules, then what other words I can use? Okay, lumps, groups, many groups of, some groups of molecules held together, that those molecules are, individualization of the molecules will not take place. Hope you understood. That is to, if when added, okay, the bottom of the dye bath is residue will be there, and a cluster, or what you call turboid. That's the dye bath seems like turboid mixture. Complete mixing of the dye not take place. That's called aggregated acid dyes. Okay, now I will discuss what is the speciality of this molecularly split acid dyes. See friends, just dissolved in water. I said they are dissolved in water, and individual molecules are separated. Each and every molecules are separated. Okay, and followed by the ionization. Just this is a chemical example is given. That is what is called here sodium is there, positive ion. When the dye added in the water, ionization takes place. Ionization, you know the chemistry. Anion, cation, the positive ions and negative ions taken place. That is separated because in silk, in protein fibers also, in protein, the opposite, suppose here Na plus is there, that is go and attract with the negative part of the fiber. Okay, negative part of the fiber, this SO3. Okay, this negative part, this SO3Na. Okay, this SO3Na, this is 15R is the dye. This 15R is the dye. This SO3Na is there. This SO3Na is split. Okay, plus and minus will be there, and these two are go and attract with the opposite ion chemicals of the what are called fibers. That is affinity taken place between the dye molecule and the fiber chemical substances. Okay, next, high solubility in water give clear solutions. See, what is the meaning of high solubility in water give clear solutions? Because when we add sugar in milk or in water, immediately it will dissolve in water. It becomes a clear. Say no milk. If you check in water, if you assume water is there, if you add water, salt, iodized salt, whatever commercial salt is there, add or sugar add, complete dissolution takes place, dissolve. Again, the container seems like clear solutions. It becomes clear. Like that, here also, highly soluble means the solubility capacity is more for this kind of dyes. So, solution, no residue will be there in the bottom of the dye bath. Such clear solutions will help to dye the fabric evenly. Dyeing defects are not, no chance of dyeing defects are there in such cases. I am not talking about the color fastness of the dyes. I am here mentioning the point dyeing level, dyeing defects. Some parts of the fabric is very dark, some parts of the fabric are light, not like even dyeing it will help to explain even dyeing. If the solution is clear, that is 100% absorption of the dye, the solution absorbed from the dye. It will help the fibers to absorb clearly the dye particle from the clear solutions. If the dye fibers absorbs the dye molecules evenly, so no chance of dyeing defects will be there. Next one is they lack affinity towards cellulosic fibers. See, this is right. Acid dye is not used for natural fibers like cotton, like linen, jute, hemp, or any cellulosic content fibers. For them, other kinds of dyes are there. Wet dyes are there, reactive dyes are there, basic dyes are there, okay, direct dyes are there. So these dyes will not lack affinity. Why? Sometimes I heard acid dye is also used for natural content fibers, but chances are very less that they lack affinity towards cellulosic fibers. Cellulosic fibers, no chance is there, because cellulose substance will not attracted by this dyes, acid dyes, but attracted by the protein fibers. They show poor affinity for protein fibers if dyed in neutral bath. See, the question here on point has come. Neutral bath. What is neutral bath? Okay, neutral bath, I told, it does not have any other activators. It does not require any activators or extra chemicals or nothing is there. Just normal dye bath, local dye bath, normal neutral dye bath. Okay, there is no push-up is required to make the attraction between the dye molecules and the fiber molecules. Just normal. But for complete dyeing, activators are required, reagents are required. For even though acid dyes are preferred for protein fibers, but the chance of the affinity between the protein fibers and this acid dyes are less is there. Means efficiency is less. What he is saying, he shows poor affinity. Poor affinity means efficiency not. They will dye. Textile fiber products are dyed by the acid dyes, but efficiency or percentage of the absorption of the percentage of the dyeing, that will be poor. So the speed of the dye has complete dyeing in textile term, in dyeing term, exhaustion, complete exhaustion of the dyes. Complete exhaustion, to take complete exhaustion of the dyes, what is required? Extra agents are required. But in neutral bath also, if no activators are there, no reagents are there, no chemicals are extra, push-up is not there, so affinity is very less. The exhaustion percentage will be very less. Okay, next point here is textile materials are dyed in presence of H2SO4, CH3COH. So to increase the affinity of acid dyes with the textile fibers, but molecules or polymers, what is required? I told reagents are required, activators are required. So what they will add? Instead of going for neutral bath, H2SO4, sulfuric acid is added, and CH3COH, formic acid. Extra addition is required. In the presence of additional sulfuric acid or what is called CH3COH, formic acid, the increase in the affinity will increase, efficiency will increase, and 100% exhaustion, at least 90 and above exhaustion can be taken place. So even the molecular split acid dyes have clear solutions, but in terms of affinity, in terms of exhaustion percentage, neutral bath gives poor efficiency, and it requires addition of the sulfuric acid or CH3COH presence is required. Oh friends, this is about the molecularly split acid dyes. I don't need to explain. Okay, whatever I written here, this list is there. Examples of molecularly split acid dyes. These are the examples. These are the list taken from the academic books, that is textile books are taken, but present in 2022, the running market, textile dyes market, most technical development might have taken place, and also the commercial names also have been changed. Even though same company, same manufacturer, same brand will be there, they might have brand might have changed, or company might have changed, or patent might have changed is there. Just for your understanding, these are the old. So I collected the dyes list from the old. Okay, if possible, I can search for now updation I will do later. Xylene light yellow 2Z, that is yellow dyes. In such a class, molecular split dyes class, this is yellow color. Yellow color, today yellow color, xylene light, yellow 2Z, xylene fast violet, xylene fast orange, sole purple, sole blue, azo germine, azo rubinol, acid orange, naphthol. Just for your examples. Why I am giving examples? The reason is students of the textile technology, college, diploma, BTech, MTech, JOC, handling technology, whoever is there, they should understand how the dyes are available in the market, in what kinds, what are the terms. In these terms, brand name will be there, and color, what color, yellow, blue, red will be there, and the symbol will be there. PN, R, G, 4BS, 2G. These are colors. Now you can search Google also. You put dyes available in the market, presents molecular split acid dyes available in the market. You can get the names, trade names. Okay, friends, this is about the molecular split acid dyes. Please subscribe my channel. Those who are not yet subscribed, please share to your friends and like it, and click the icon bell to get the notifications. Thank you very much.